We continue now with the other very large backsheet maker dominating the market, and that is Cybrid technology. We're very happy to have with us Stephen Gong, who is the Senior Product Manager. And Stephen will talk about innovations in module encapsulation, polymer solutions for advanced cell technologies. Stephen, the floor is yours.
Hello, you hear me?
Yes.
Yes, no. So, hello everyone. My name is Stephen. Where is the presentation?
You have to click on the green share button at the bottom.
Okay, just one. Okay, I find this. Okay, can you see my screen now?
Slowly coming. Here it is.
Okay. So today, I'm going to talk about innovations in module encapsulation, mainly about the polymer solution for advanced cell technologies. I have two topics, mainly first one is a backsheet and another one is for encapsulating film. For backsheet, first of all, I need to present to you the transparent backsheet. For glass backsheet solution, bifacial, people are using a lot of total clear or even the white grid or even black grid backsheet. So Cybrid now is doing these two kinds of products that can do these three kind of tailored products for our customers. Even you can make black bifacial modules with the black grid version. Yeah, this slide is mainly about the major structure of clear backsheet in the market. So we are doing the PVDF version, and we're also doing the coating version. Since the backsheet is very similar because the WTR is around 2 grams per day. Because of the encapsulant film, the WTR is very different from EVA to extruded EPE or POE. So we think if you want to guarantee the module PID and the damp heat performance, it's better to use POE for encapsulant. But some people is using EVA or they can use EPE. But this really depends on the environment of the final modules. We also found some interesting phenomena after the screenshot testing, like damp heat, UV, TC, UV, TC, UV, TC, and UV. This screenshot test that can be tested for module cracks simulation. We found some transparent backsheets, they are not able to pass this test, so they will we find micro cracks on the several steps. So for this we suggest that at least if you want to use the transparent backsheet, it's better to pass the sequential test to guarantee the module or reliability. Then I going to talk about the black high reflective version. That the black backsheet is mainly double black or inner layer black. Due to the cost reason, people use standard black is inner, which is inner black a lot. But after that we have the higher reflection version. Coating. This kind of coating has more than 55% reflectivity in the near IR nanometers. So this year, at this wavelength, if you got 55% reflection, the module power would be very around 2%. Yeah, we also have this recommendation for the customers to use the different kinds of backsheet. Even if you can use the backsheet with pattern or even use a high reflective version, you need to choose the right encapsulant film for the modules. This is the data that we collected after some tests for different modules. We did a standard black. We did a standard black with we did some conventional POE+ cells. Now we do some bifacial cells with black grid modules. Also, we do the black higher reflection version with bifacial cells. And after that, we can see the power gain is around 2.15%. The other is about 1%, 0.66%, or the standard black has nothing gain for power. This is the product's performance after the pressure cooker and oven test and also damp heat test. We guaranteed the aging test for color change for data B, and also the FTIR are stable. Because of the previous coating was not stable, people found the color change a lot. So Cybrid already successfully solved this issue. The other topic is the fluorine-free backsheet. You know that due to the European environmental regulations, and also we will always see some news in the PV, even the rooftop or the field installation. There are fire accident on the modules. So the major issue is when the module is working safely, it is okay, no problem. But if a module is using fluorine backsheet, when the module is on fire, it is create a lot of toxic gas like HF, which is very seriously pollution air, and also that will be very harmful for the human body. So this is the major issue of the fluorine backsheet. So we are doing the fluorine-free backsheet mainly for the rooftop application, like residential or in the plant roof or in the roof that has the concrete base. Because of this different environment, we have 5-point recommendation for the rooftop backsheet solution regarding for UV and heat resistance, also the humidity, fire protection, and also the recyclability of the residential market backsheet selection. We have two options backsheet for non-fluorine products. The first one is the PPF structure. Though this kind of structure we can sell into the market more than 7 years, and the PF structure we have about 4 years or 5 years experience in the market. So we just changed the inner layer as fluorine-free coating. So we do these two options to the market. Then I'm going to talk about the encapsulation film solution. The first one is for HJT. You know, HJT now is very hot topic for the PV industry. Research was very interesting from Unreal and Slack from this year. They studied the different cell technology under UV radiation. They find the HJT cells are very sensitive to UV and causing the power drop very dramatically. So for this case, we have a study about the encapsulation solution. For this group is for UV-free type EVA or maybe POE or EPE. We have did some modules. In this group, we do some UV cutoff version, and this group we have test for the UV conversion film. You see, this group is higher power, but this is less reliable because the HJT is very sensible for UV light. It's causing the TCO degradation. And this group, even if you use a UV cutoff version, but the output is much lower than before. So this is you lose the power. In this case, if you have a UV conversion encapsulant solution, the power output is higher and also stable. Means after field exposure for at least 1 month. So HJT module using light conversion film have the power again about 1.5%. You know that for 0 BB or non-bus solutions, we at Cybrid we do integrate the film like encapsulant layer or mid layer or adhesion layer, or the 2-layer structure, encapsulate layer and also the adhesive layer to the cell. We did some tests for a lower CTE, and also we do some lamination, and we do some cross-cutting from the cell to see the ribbon and the encapsulant situation. It was good also on the cells after aging test. So this is a really how to say very good solution to be expected for HJT 0 BB application. You know, the HJT also have another issue, is the adhesion problem. According to our research, we found some standard encapsulant film like EPE. They only have around 25 or 35 Newton adhesion to HT cell because of the TCO layer was quite poor bonding performance due to the physical property. So we have to do a high bonding version EPE that can get more than 55 or even 70 Newton adhesion. So that means that the higher bonding strength should be guaranteed for the module reliability. We also found some interesting tests for high bonding to the cells, and also the aging test. We do some tests after MP combined UV. At the beginning it was 62 Newton. After that it has 34 Newton. You know that we test a lot of films with the cells. It has different adhesion, as you see here. Some are quite low, some are quite high. So after HJT, I'm talking about the TOPCon solutions. You know, if you see the TOPCon, the different solution on PERC, on TOPCon, and HJT, they currently the front encapsulant and the rear encapsulant are quite variable, because people can use POE plus POE, can use EPE plus EPE, or even they can use EPE+white EVA or POE+white EVAs. This is for a glass-backsheet solution. For glass, they have 3. So currently, if you use a round ribbon from 0.26 to 0.29 nanometers, millimeters diameter, can use POE from 360 to 400 grams, or EPE from 410 to 460 grams. This is a very different from each of our customers. So we found some issues on the TOPCon cells because we did EDS tests to find the aluminum element from the silver paste. When you have aluminum, it will causing a problem of acid reaction with it and create some chemical actions. Should be a problem for TOPCon cells. We did several tests for the different module setup. You see, we do the rear and front encapsulant film differently, and the front side we use also different. Find some interesting data shows the front POE or EPE for damping 2,000 hours seems okay. But if you use a white film, this should be cross-linked, and also you need to evaluate the bonding property. For POE, is the best choice, but the price is also high. So the other issue of EPOE is the additive that is coming out from the POE is very easily causing some issues. So at Cybrid, we do anti-slip solution, means to stop the movement of the cell shifting or string shifting. So we do some adjustment on the process of the mixing and film making, and also we do some improvement from the embossment. And then we also did a method for inhibiting the precipitation of auxiliaries. This will be the final method. We have also tested the anti-slip version POE for tests to see the movement of the film on the glass. And we also do some cooling tests after 24 hours to look the movement of the film on the glass. So EP structure will be a very new solution also from Cybrid. We do EP means one film with co-extruded E and P. The POE is facing the cell, and also the EVA is facing glass. If this solution will be successful, this can solve the problem of EVA and POE. Also, if this solution will be successful, for sure you can use lower gram weight for control of the cost and the lamination. Also, for glass-backsheet solution, we did some tests with POE plus POE, POE EVA, POE is cutting off EVA, or POE plus cutting off EVA improved. Also, POE plus white EVA, EP plus EP. It seems that the conventional encapsulant film would not pass the damp pit for N-type cells like TOPCon. And the dummy modules are tested for simulation. Should also be a guide for large size modules. So this is also some tests on our test after pressure cooker 48 hours. We found some brownish of the ribbons between the cells for POE plus EVA solution. But POE plus POE will be okay for glass backsheet and glass models. The TOPCon cells, people are finding a lower water transmission backsheet to solve the water version issues. So we compare the POE plus POE with water or vapor transmission about 2 grams backsheet after pressure cooker 48 hours, 96 hours. There has been some change. Also, if you use a lower WTR backsheet around 0.4 grams, it seems the yield test should be better, but not really perfect. So we have a summary for the TOPCon solution for glass backsheet module and also for glass modules. If you see glass backsheet modules, you can use POE plus POE or POE plus EVA or white EVA. For glass, you can use POE plus EVA or EPE plus EVA. This should be a cost down version because some people is using POE plus POE. For future, we hope that if the EP structure works, should be more easy. So both layer you can use front use transparent EP, back layer you use white EP. For glass you can use both EP for encapsulation. So I give you a brief summary. So for the backsheet solution for future should mainly be the transparent backsheet. Even the black reflection version or non-fluorine type should be the trend. For HJT will be the light conversion type and high bonding version EPE or EVA. This is already been some of module maker is changed to this way. And for TOPCon encapsulation should be POE plus POE or EVA plus EPE plus EVA for double glass modules. For glass backsheet modules should be POE plus EVA or POE plus white EVA. The new EP, if it works, this should be a very good cost down and process solution. So thank you.
Thank you, Stephen. Great overview. One quick question regarding the fluorine-free offer you have. How is the reaction from the market to that? How much is this wanted?
You know that in the European market is not how to say, is not 100% want the non-fluorine. But if you mention to the customer that your backsheet is fluorine-free, they say we prefer this one because of the fluorine they don't like. They ask you to provide some documents to prove that your material is fluorine-free, and they also don't want to be in trouble after maybe 25 years for the recyclability issue. Also, they, for the REACH and the WEE regulation, it is not saying that the non-fluorine is bad, but their regulation is much harsher than before. They ask you to taste the PFCA for a very lower content. So anyway, the market reaction is they prefer the non-fluorine base.
But only in Europe. That's the only market where it is at the moment being used.
Yeah, European market is more likely. For China and the Asian market, the people start to be aware of that issue. They start to thinking about that.
Okay, thanks. There are some more questions in the chat. If you could answer them, that would be nice.
Okay.
Thank you so much. Take care.
Bye-bye.
Okay.